NASA says its Pioneer 1, the most distant human-made object known to man, is sending usable information to Earth again. In the vast universe, we have no clue what it is, aside from the fact that we can study it. Voyager 1, the famous space probe launched by NASA more than 4.5 decades ago, has recently sent back a message that has sent shock waves through the academic community. After traveling nearly 14 billion miles from Earth, Pioneer 1 has made a discovery so significant that it has changed its mission, redirecting it toward our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a priceless anomaly, or something even more extraordinary? In this gripping analysis, we'll unveil these stunning revelations, as Voyager 1 has recently made a startling discovery that caused it to suddenly redirect toward Earth. The twin Voyager probes, if certain fortunate events hadn't aligned, might never have left Earth. In this case, the aligning stars were the 4 largest planets in our solar system. Nearly 5 decades ago, these planets were slowly aligning in a way that hadn't occurred since Thomas Jefferson's presidency in the 19th century. This fascinating planetary arrangement initially went unnoticed. The first person to recognize its importance was Gary Flandreau, a dual-degree student in aerospace at the California Institute of Technology. Back in 1965, when space exploration was just beginning, Flandreau, working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, was tasked with determining the best method to send a space probe to Jupiter, or beyond, to Saturn, Uranus, or Neptune. Using a simple pencil, Flandreau carefully plotted the orbital paths of these giant planets and made a groundbreaking discovery. In the late 1970s and early 1980s, all 4 planets would align in such a way that they could be visited in a single mission. This arrangement meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, dramatically reducing travel time. Flandreau calculated that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12. However, there was a catch. This planetary alignment occurred only once every 175 years. To take advantage of this unique opportunity, a spacecraft would need to be launched by the early 1970s. NASA seized this rare chance and built 2 spacecraft for the mission, Voyager 1 and Voyager 2. These probes were sent on a monumental journey to explore the outer planets of our solar system. Thanks to the planetary alignment and Flandreau's visionary calculations, the launch of the Voyager twins on September 5, 1977, marked something truly extraordinary at Cape Canaveral, Florida. Voyager 1 embarked on its spectacular journey into space, propelled by a powerful Titan IIIe rocket. Just a few weeks earlier, Voyager 2 had been launched on August 20, 1977. Voyager 1 joined this grand adventure, beginning its voyage into the vast universe along a more direct path. Their primary mission was to study the massive gas giants of our solar system, such as Jupiter and Saturn, along with their various moons. However, these daring space explorers exceeded all expectations, venturing far beyond the known boundaries of exploration. They traveled farther and longer than any other spacecraft in history, breaking numerous records along the way. The Voyagers ventured into interstellar space, an utterly mysterious region beyond our solar system. Despite being over 12 billion miles from Earth, they continue to astonish scientists with their incredible discoveries. Most recently, they made a finding so shocking that it has captivated everyone. The Voyager twins achieved several remarkable milestones. Decades ago, they studied the moons of Jupiter and Saturn, surprising scientists who initially believed these moons to be dull and heavily cratered like Earth's moon. Instead, they turned out to be dynamic hubs of activity. In 1986, Voyager 2 became the first spacecraft to visit Uranus, and 3 years later, it passed by Neptune, a feat unmatched by any other spacecraft. As these probes continue their incredible journey, NASA has employed clever strategies to keep them functional. Unnecessary parts, such as redundant instruments and heaters, have been deactivated to conserve power. This approach aims to keep the spacecraft operational until at least 2030. For the dedicated scientists and engineers who have been part of this remarkable mission from the start, it is a bittersweet blend of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a stunning revelation emerged from the depths of space. Voyager 1's discovery, data transmission, and revelation. At the beginning of their extraordinary journey decades ago, the Voyager spacecraft stunned experts by providing the first close-up views of Jupiter's and Saturn's moons. These moons, which astronomers had assumed were dull and heavily scarred like our moon, turned out to be active worlds. Voyager 1 reached Jupiter in March 1979, just a year and a half after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with VidCon cameras that used filters to capture full-color images. Interestingly, these cameras were incredibly stable, spinning through space at a rate more than 10 times slower than the hour hand of a clock. This ensured the images they captured were clear and sharp. During their mission, the Voyagers took over 33,000 photographs of Jupiter and its moons, each revealing new and captivating details. For example, Europa, one of Jupiter's 53 named moons, was found to have a fractured icy shell estimated to be over 60 miles thick. As the spacecraft departed from the Jupiter system, they gained a speed boost of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them toward interstellar space. Saturn, the Voyagers took different paths. Voyager 1 navigated through Saturn's majestic rings, enduring countless impacts from tiny dust particles, before flying past Titan, a moon shrouded in an orange haze. From there, it ventured northward out of the plane of the planets. Pilgrim 2's journey and discoveries. Pilgrim 2 proceeded with its performance process, showing up at Uranus and Neptune in 1986. During its visit to Uranus, Pioneer 2 found 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Just a short time after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after launch, killing all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to go into space. 3 years later, as Voyager 2 zoomed around 2,800 miles above Neptune's striking blue methane sky, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our vast neighborhood, with surface temperatures falling to a stunning -235 degrees Celsius. The moon's icy volcanoes were another astonishing discovery, launching nitrogen gas and fine particles up to 5 miles into its atmosphere. After Voyager 2's mesmerizing images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the grand tour nearing its conclusion, NASA extended the mission, hoping the spacecraft would venture into interstellar space. Renamed the Voyager Interstellar Mission, the probes were set to continue their journey into the unknown. On Valentine's Day in 1990, the spacecraft turned its camera back towards the inner solar system and captured 60 final shots. One of these, famously referred to by Carl Sagan as the pale blue dot, showed Earth from an astonishing distance of 3.8 billion miles. In the image, Earth appears as a tiny speck, barely visible against the vastness of space, illuminated by a faint beam of sunlight reflecting off the camera's optics. Exploration beyond the heliosphere. The Voyager mission's passage beyond the heliosphere in August 2012 marked a monumental achievement. By crossing this vast region of charged particles released by the Sun, Voyager 1's extraordinary feat became widely recognized the following year, when a study was published in the journal Science. The spacecraft's plasma wave instrument detected a powerful solar outburst between April 9 and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating the spacecraft had entered a region of higher particle density than within the heliosphere. Initially, it seemed surprising that electron density was greater in interstellar space than near the Sun. However, scientists explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, scientists pinpointed the official departure date as August 25, 2012. This determination relied not only on electron movements but also on measurements of charged solar particles gathered by the spacecraft. Coincidentally, this was also the day Neil Armstrong, the famed Apollo 11 astronaut, passed away. On this significant date, Voyager 1 recorded a 1,000-fold decrease in solar particles and a 9% increase in cosmic rays originating from outside the solar system. These findings illuminated the dynamic and ever-changing nature of our vast cosmic neighborhood, showcasing the complexity of space exploration. Voyager 1 had reached a remarkable distance of 11.25 billion miles from the Sun, approximately 121 astronomical units. The role of the Deep Space Network, DSN. NASA's Planetary Science Division continues to study the solar system using various methods, including flybys, orbiting, landing, and sample return missions. The Voyager missions were the pioneers of this approach, laying the foundation for future exploration. The concept of gravity assist, which uses a planet's or celestial object's mass to alter a spacecraft's speed and direction, was crucial to Voyager's successful exploration of the outer planets. Another critical component of the Voyager missions was the Deep Space Network, DSN. This system functions as a global web of radio antennas that enables communication with distant spacecraft. With stations in California, Spain, and Australia, these giant dishes, some as wide as 70 meters, act as space amplifiers. They capture faint transmissions from spacecraft and transform them into usable data for scientists. The DSN also sends commands to the spacecraft, ensuring their missions stay on course. Operating 24/7, the DSN serves as humanity's vital link to spacecraft exploring the outermost reaches of space. This robust communication system keeps the Voyager missions alive, even as the probes journey into interstellar space, venturing far beyond the solar system. Challenges and longevity of the Voyager missions. The Voyager spacecraft have encountered numerous challenges during their long journeys. Voyager 1, for instance, is equipped with 3 onboard computers, including a flight data system that gathers information from scientific instruments and transmits it to Earth in binary code. Recently, however, Voyager 1's flight data system appears to be stuck in a loop, repeatedly sending the same pattern of ones and zeros back to Earth. This issue was first observed on November 14, when the spacecraft's communications unit began malfunctioning. While Voyager 1 can still receive and execute commands from mission control, the problem means no new scientific or engineering data is being transmitted. NASA engineers have attempted to restart the system, but so far, no usable data has been recovered. They are now working to identify the underlying cause of the issue, which could take weeks to resolve. Despite these challenges, the Voyager missions have far exceeded their initial expectations, becoming the longest operating spacecraft in history. Researchers continue to study the dynamic changes in particles and magnetic fields as the probes venture farther from the heliosphere. The ingenuity and dedication of the mission teams ensure the legacy of the Voyager missions endures, even as they traverse the vast unknowns of interstellar space.